Good afternoon, Chairman and all participants. It's my greatest honor to present to you today the effect of different surface treatment on the partial stain of hybrid ceramic. The outline is as follows. In the present, there are various kinds of restorative material available in the market. Ceramic is one of the most popular two-line restorative material. The material was developed to improve the property and classify into three groups: glass-based ceramic, resin matrix ceramic, and oxide ceramic. In this study, resin matrix ceramic was experimented. Resin matrix ceramic is the combination between ceramic and polymer, producing a material less brittle than conventional ceramic and improved flexibility and less abrasion than glass ceramic, more opaque and able to be repaired with resin composite. Resin matrix ceramic is divided into two subgroups: resin nanoceramic and polymer infiltrated ceramic network. In the study, the theta-enamel polymer infiltrated ceramic network was experimented. It consists of 86% feldspar ceramic and 14% dimethyl polymer consisting of UDMA and the tech-DMA. The bonding between ceramic and resin composite chemical bonding can be achieved by silent and adhesive system. Mechanical bonding also enhances the bond strength, such as the hydrophilic acid, sandblasting, tribochemical silica coating, and the tribochemical silica coating was found to yield similar results to sandblast. The adhesive used in this study is single-bond universal adhesive consisting of silent chemical adhesion. It enhances the chemical adhesion between organic and inorganic substrate. Silane is bifunctional monomer, which contains a silanol group that reacts with ceramic surface and a methacrylate group that copolymerizes with the organic matrix of composite. The silane used was the line X ceramic primer. According to the study by Thanaporn et al. In 2016, application of single-bond universal adhesive followed by silane yield greater shear bond strength between resin composite and ceramic. Because silane causes hydrolysis forming silanol group, then silanol in each group will link and bond, becoming polysiloxane on ceramic surface, making it monolayer hydrophobic, having better bond with resin composite. The silane also gives more wettability of material surface, increasing the bond strength. The objective of the experiment is to compare the effective valid surface treatment on shear bond strength of repair hybrid ceramic with resin composite. On the next part will be the material and method. The 40 specimen of hybrid ceramic block theta-enamel size 6 by 11 by 2 mm were prepared by cutting using a water-cooled diamond blade with a low-speed cutting saw by isometric machine. Each specimen was fixed in PVC mold with diameter of 10 mm and height of 10 mm with formaldehyde self-cured acrylic resin. Then all specimens were polished with silicon carbide paper plate, each coolness for 1 minute with a polishing machine until the surface area was flat and smooth and clean with ultrasonic cleaner for 5 minutes. Then all specimens were randomly divided into 4 surface treatment subgroups. The group 1 is controlled group. Silane coupling agent was applied for 60 seconds and lightly air dried, then it was applied with second-bond universal adhesive for 20 seconds. Air dry and lacquer for 20 seconds. On group 2, specimens were applied with 5% hydrophilic acid for 60 seconds, rinsed, then air dry, then applied single-bond universal adhesive. In group 3, they were air ablated with 50 micron particles and blast for 15 seconds perpendicularly, distancing from 10 mm, then applied with single-bond universal adhesive. In group 4, were glided with sandpaper number 120 gliding in one direction for 4 seconds by polishing machine. Then they were applied single-bond universal adhesive. After all subgroups were applied with the hydrolyzed silane for 60 seconds and light air dry, then single-bond universal adhesives are applied for 20 seconds and air dry for 5 seconds, and light cool with intensity of 1100 milliwatt per square centimeter for 20 seconds using an LED light cooling unit. Finally, the laser composite filter 350XT was filled on the straighter surface using a metal split mold size 2 by 4 mm to standardize the dimension of the composite and light cool for 40 seconds. All bonded specimen was stored in distilled water at 37 degrees Celsius for 24 hours. Before shear strength testing with universal testing machine, the Shimasu, the interface between the theta anemic specimen and laser composite was loaded by force with a closed head speed of 0.5 mm per minute until fracture occurred. Then shear strength was recorded in megapascal. After testing the shear strength, all specimen failure was evaluated using a stereo microscope on sample from each group was examined under a scanning electron microscope to determine the treatment surface. All statistical analyses were performed using SPSS program version 26.0. Shear strength data was submitted to the Jiracharoenwongsa wheel test to check for normal distribution of the data. Normal distribution was found in all subgroups, one way and over, followed by tricky tests performed to analyze the difference between groups. In all tests, level of confidence was set at 95%. On the next chapter will be the layout. The main standard deviation of the shear strength value of different surface treatment to the hybrid composite are summarized as shown in the table. The lowest bond strength value were found in the control group with 5.8 megapascal. The highest bond strength value were found in the hydrofluoric acid with 13.0 megapascal. One way ANOVA and post-hoc tricky test show that the mean shear bond strength of hydrofluoric acid group and the Sandblast group were significantly higher than the control group and sandpaper. Still, there was no significant difference between the hydrofluoric and Sandblast or the Sandblast and sandpaper. After testing the shear strength of specimen failure mode was evaluated using a stereo microscope. The failure mode was classified into 3 types adhesive failure. In all test groups, the predominant failure mode was mixed failure, except in the control group. There was adhesive and mixed failure, seen in the hydrofluoric acid group, Sandblast and sandpaper group. The figure shows the surface of the material under stereo microscope with 2.5 times magnificent. It shows the surface of fracture. Area in the white circle is the bonding area, and the letter A indicates adhesive, and the letter C indicates ceramic. The figure on the left shows adhesive failure, which is fracture at interface between ceramic and adhesive. In the center figure shows mixed failure, showing both fracture at adhesive and ceramic surface. On the right figure is cohesive failure, which is fracture at the ceramic internal surface, indicating the fracture of the ceramic. One sample from each group was examined under a scanning electron microscope to determine the treatment surface at magnification 40 and 2000 times, respectively. The hydrofluoric acid, Sandblast, and sandpaper group show the surface irregularity with the several distributed micropore and gaps. In contrast, the control group show only micropores. And the next part is the discussion. In the group of hydrofluoric acid etching, the acid will react with the glassy matrix of the hybrid ceramic, removing the glassy matrix from the surface of the hybrid ceramic, making its surface become porous, increasing the roughness of the material, forming the micromechanical interlocking between the ceramic and the adhesive, and it also increasing the surface energy and surface area for chemical bond with the adhesive, thus increasing the bond strength between the ceramic and laser composite. The sandblasting is blasting of aluminum oxide particle to the surface of the material, increasing the surface roughness and surface energy, increasing the bond strength between the ceramic and adhesive. However, Papadopoulos' study in 2020 shows the crack formation in material has been observed with larger size particles of 120 micrometer and the duration of the procedure should not exceed 30 seconds. Therefore, consideration on the size of particle and duration of the sandblast is recommended. In the study, silicon carbide paper was used to imitate the effect made by medium coarse diamond bar, which is used in clinical sedation. Surface preparation with silicon carbide paper create deep grooves and streaks, which form macro and micro retentive area, promoting the interpenetration of the adhesive to form a succinct bond. After each mechanical surface treatment, silent and single bond universal adhesive will be applied on the surface of material, in which silent will form chemical interaction according to lethal chemical and mechanical surface treatment are both required to increase the bond strength of the repelling the material. Hydrofluoric acid is the most effective surface treatment method for glass ceramic. In conclusion, the type of different surface treatment significantly affected J bond strength value, which the hydrofluoric acid group is the highest. However, the effect of hydrofluoric acid on the oral tissue are potentially harmful. The rubber dam and protection glass application during procedure is recommended with high power suction. Anyway, if hydrofluoric acid application is not indicated, the sandblast or gliding with dental wear are recommended as these procedures improve addition to the resin composite to the hybrid ceramic. This study only investigates the shape bond strength within 24 hours for the immediate bond test of a surface treatment of resin composite bonding on theta ceramic. Further study investigates the effect of other type of ceramic and thermocycling is recommended. The study was supported by London University Research Grant and CM Thailand for supporting the material. Thank you sincerely, Dr. Nasaya and Dr. Apapon Nitipati for their support and advice. Furthermore, we are thankful to the Dental Material R&D Center, Faculty of Dentistry, Chulalongkorn University for the quality education and providing equipment and material in our study. Finally, we are delighted for all support from our friends and family throughout this study. We are willing to humbly accept your suggestions with more admiration. Thank you.
Thank you very much, Hitch, for presentation, for the good presentation. So for the audience, is there any question that you would like to ask the presenter? If there is no the question from the audience, I would like to ask a question. One question. I have a question. Your study, you use the silicon carbide paper, right, to imitate the effect that made by diamond burr. Do you have any evidence that shows that the surface that prepared by the silicon carbide paper and the diamond burr is similar or the same?
Well, we have reviewed some paper, and there are some papers that say that the silicon carbide paper can imitate the effect of the diamond burr that we use in the clinic.
Yeah, I mean, how can they say that it can imitate? Like, can you explain a little bit more?
From reviewing the paper and the study.
Okay, like they measure the surface roughness of the surface that prepared by diamond burr and the silicon carbide paper, something like this.
Well, yes.
Okay, so that's why like that's why you use this one. And for the group so you would like to know the effects only for the surface treatment, not from the bonding, right? Because you use the same bonding. Is that the intention, right?
Yes, correct. That's correct. We just want to test out
The surface treatment.
treatment for the Sandblast.
And what do you think about the result that you got, that about the HF and the Sandblast have the same mean shear bond strength? It's not statistically significant, right?
Well, yes, from our studies.
I mean, from what I see from the result.
Yes, it has been seen that from the layout, I'm going to show you the SAM photo here.
It looks similar.
Yes, they seem to look similar, and they are significantly different.
But I mean, from the discussion, you said like for the Sandblast, it can cause the crack.
For this, from reviewing the study, if we use the Sandblast particle and the duration in the right amount, it is not going to cause too much crack. It is not going to weaken the structure of the ceramic too much. Okay, so in this study, how long do you use the Sandblast? Well, as in the discussion, it says that from reviewing the study of the
30 seconds. If you use more than 30 seconds, it will cause micro crack, right?
If we use more than 30 seconds, and if we use 120 micrometer particle, it is going to cause the micro crack. So you reduce the time, 15 seconds. Yes. So we use 8 for only 15 seconds and 15 micrometer. Okay. So and it's quite good result. Yes. I mean, comparable to the HF.
Time is up already, Ajahn Phakphu.
Okay, thank you, Ajahn Kittakorn. And thank you, Peach, for very good presentation, all the answers.